hand. The world of technology died, and all we had was our pen and paper. We need to be able to survive to find those inverses. Okay, so let's first make sure we remember how to solve this system using row operations. Let's get a quick refresher. 2, -3, bar 1, 1, 5, and 20. Lower left. I didn't realize I was writing so big. How do I get that to a 0?
Times row 1 by -1/2.
Good. Let's do a -1/2 R1 plus R2. So that stays a 2, that stays a -3, that stays a 1. So -1/2 of 2 is -1. -1 times 1 is 0. -3 times -1/2, well, that's 3 halves. 3 halves plus 5 is the same as 3 halves plus 10 halves, so 13 halves. -1/2 times 1 is -1/2 plus 20 would be 19.5. 19.5 is an improper. 2 times 19 is 38 plus 1, so 39 halves. Yeah? Yep, so now let's get a 1 here. So multiply by the reciprocal. 2/13. So let's do a 2/13 R2. So row 1 still has not changed. So 0, 1, and then, yeah, so it would be 39 divided by 13, which is 3.
-3 to 0.
Yep, let's get that to a 0 next.
3 times R2 plus R1.
Perfect. 3R2 plus R1. So R2 stays the same.
0,
2, 0. Nope, 3 times 3 is 9. Yep, 9 plus 1 is 10. Last move. Yeah, row half of your row 1. So we get 1, 0, 5, 0, 1, 3. Good. So our solution is 5, 3. Perfect. All right, so now the beauty of what we've been doing is you've been practicing this whole entire time how to find an inverse of a matrix. Kind of. Okay?
The opposite of this.
Huh?
So are we going to take
Not really the opposite of this. But what we've been getting it to at the end is a special type of matrix. Notice that we only have 1s on the diagonals and we have 0s everywhere else. If we had a 3 by 3, I'm going to erase this, is everybody okay? If we had a 3 by 3, what would that look like? 1, 1, 1, 0, 0, 0, 0, 0, 0, right? So you have 1s on that diagonal, 0s everywhere else. That has a special type of name, and that is called an identity matrix. So you've been working with identity matrices this whole entire time without really knowing about it. Now we're just going to put a name to it. Okay? So your identity matrix, which we usually use a capital I to name, is where you have 1s on its main diagonal and 0s elsewhere. So you've been finding an identity matrix this whole entire time, which is great because it should make finding an inverse pretty easy because you know how to get to that identity matrix on the left-hand side. What's going to happen now is we're just going to have more values on the other side of our bar of our augmented matrix. Okay. All right, so when we find the identity matrix, what we're going to be doing is multiplying to show how the identity matrix will always get you back to that A. So the identity matrix for multiplication, if we let A be a square matrix with n rows and n columns, and we let I be an identity matrix with the same dimensions, it should not matter if I multiply matrix A by I or I by A, it will always result back to the A. Okay, so if we think about all the math that we've done so far, if I think about the identity property of addition, what number can I add to 4 to not change it? 0. So 0 is your identity property or your identity number of addition. If I had 4 times some number that would not change its identity, what would that number be? It would be 1, right? So you have identity properties of addition and identity properties of multiplication. So now we have an identity property of matrice multiplication. It's just that we have to turn it into a matrice, which now becomes the identity matrix. You do not need to do this in your notes unless you want to. If you want to practice multiplying. If I were to multiply this 2 by 2 by its identity matrix, what will we get? Well, the resulting matrix would be a 2 by 2. So now let's remember how to multiply. Yep, so it'd be 2 times 1 plus negative 3 times 0, which would just be 2. To get row 1, column 2, 2 times 0 is 0, plus negative 3 times 1, which is negative 3. To get row 2, column 1, 1 times 1 is 1, 5 times 0 is 0, adding that gets you 1. And then column 2, or row 2, column 2, 1 times 0 is 0, 5 times 1 is 5. So, does it change? No. Do I need to do it the other way? Or you believe it's going to stay the same? So if I put this first, that second, it would stay the same, right? Okay, so the identity matrix is kind of similar to what the identity properties of addition and multiplication are. It's not going to change the matrix when you do that multiplication. So, what do you think this one would turn into?
3, negative 4, 3, 2, 1, 5, 8, 7.
All right, so if you don't believe me, again, you don't have to write this stuff. This is an obvious. 3 times 1 is 3. Negative 4 times 0. 3 times 0. So then I would result with a 3. Now let's do column 2. 3 times 0. Negative 4 and 1. Negative 4. 3 and 0 is 0. Now go over here. 3 times 0. Negative 4 times 0. 3 times 1. 3. 2 times 1. 2. Negative 1 times 0. 0. 0. So that would just be 2. 2 times 0. 0. Negative 1 times 1. Negative 1. 5 and 0 is 5. 2 times 0. Negative 1 times 0. 5 times 1. 5. 8 times 1. 7 times 0. 6 times 0. 8. 8 times 0. 7 and 1. 6 and 0. 7. 8 and 0. 7 and 0. 6 and 0. 6. Okay? It turns into the same thing. So anything times the identity matrix will just be itself. Got it? That was the purpose of that. Okay, so how do we actually find the inverse of a matrix? So the inverse of a matrix. If you have matrix A, and it's a square, let's say, n by n matrix, and you have matrix B, and A and B have the same dimensions, so they're both n by n, and they're both squares. we can decide whether they are inverses of each other by multiplying the two together and seeing if they result in the identity matrix as their products. So if A is a square n by n matrix and B is a square n by n matrix, they would be inverses of each other is if you found the product of them and they end up being the identity matrix, which is what this says right here. So A times B should be the same as B times A, which should get you to the identity matrix I. And just like when we found the inverse of functions, you use this little -1 exponent. That's not a power, so you're not going to think exponent properties. That just is your notation for inverse. So this is telling us that that's the inverse of matrix A. All right, so you're going to have a few homework problems where you're going to have to check whether two matrices are inverses of each other or not. And all we're going to do is multiply those. Are you ready? Okay, so here's our first, oops. Well, I don't want to do that. I want to do one that's, ignore that. Do we have one that's doing it? Nope. All right, well, let's practice one. I guess I didn't have an example. How about, I have cheeks. I want to make sure it's one that works instead of one that I just make up. Let's go with 2, 3, 1, 1. And -1, 3, 1, -2. So the question is, are they inverses of each other?
Yeah.
You already did the multiplication?
Yep.
Or is it just because I said I want to pick one that works?
She just said
All right, so let's see how it works. 2, 3, 1, 1 times -1, 3, 1, -2. All right. Yep, regular multiplication. So this is a 2 by 2. This is a 2 by 2. The product's going to result in another 2 by 2. I'm going to set that up. All right, so row 1, column 1. 2 times -1 plus 3 times 1 will get us what? 1. Good. Row 1, column 2. So row 1, column 2. 2 times 3 plus 3 times -2 gets us 0. Row 2, column 1. 1 times -1 plus 1 times 1 is 0. Row 2, column 2. 1 times 3 plus 1 times -2 gets us 1. Is that the identity matrix? So our answer would be yes, they are inverses of each other. So yes, inverses of each other. Go ahead.
If 3 and 1 and 3 and 1 are the same, like the two top and left, those are like if they're the same, is it going to be an inverse?
Not always. Because sometimes inverses get really funky and they have fractions in the inverses of them. So it's not always going to be the case. Okay. All right. So that's how we check to see if matrices are inverses of each other or not. So now we need to think, well, if I give you a matrix, how would I get to the inverse? Is our actual goal now. So here I gave you a matrix and its possible inverse, and that gets you the identity matrix. So now we want to try to find the inverse, which means we're going to have to use the identity matrix. So here, I have steps listed out nicely for you. don't know if it's beneficial to write them down or not, probably. So steps for finding an inverse matrix. Step number 1. You're going to create an augmented matrix where your matrix A is on the left side of your bar, and you're going to put the identity matrix on the right side of your bar. So if your A is a 2 by 2, then you're going to do a 2 by 2 identity matrix, which is what this means right here. If your A is a 3 by 3, then you're going to do a 3 by 3 identity matrix. If your A is a 4 by 4, then you would do a 4 by 4 identity matrix on the other side. So we're going to have numbers on the left, and we're going to have ones and zeros on the right side. Okay? Step 2. We're going to perform row operations to flip it so that, and this should not say A, that should say B. That's a typo I gotta fix. You're going to perform row operations on that matrix that we just created so that we get only ones and zeros on the left, which you guys know how to do because you've been doing that when you've been solving. So once you get that identity matrix on the left side, you're going to have some matrix, we're going to call it B, that's going to be on the right. And whatever those numbers are that are going to be on the right are going to be your inverse matrix.
So we're trying to find B.
Yes. Okay, so once you have this flipped, whatever numbers are over here now are going to be your inverse matrix, which is pretty much it. Okay, so you guys have been doing these row operations, nothing new. It's just, now we're going to have a little bit more numbers involved with our row operations. But we don't really care what's happening with the numbers on the right side. All I do care about is those left numbers and getting them to the identity matrix. Okay, so that matrix B is going to be the inverse of A. That's what that says right there. All right, ready to see it happen? Let's do it. Starting off with 3 by 3. Why not? Or do we want to start off with a 2 by 2?
Start with
3 by 3? Okay. So here is matrix A. 1, 0, 1. 2, negative 2, negative 1. 3, 0, 0. We want to find the inverse. Yes. Yep. So I'm going to set this up. I'm just going to turn this into a bar, save myself some space. And then I'm going to put the identity matrix on the other side. All right, lower left. So don't even worry about what's happening on the right side right now. Just focus on the left side and getting that to the identity matrix. So lower left, what are we going to do, Justin?
Times row 1 and negative 3.
I like that. So let's do a negative 3 R1 plus R3.
Wait, why is there a 1?
Oh, that should be a 0. Thank you. Thanks. Yeah, you can easily turn a 1 into a 0, just like I did there. All right, so rows. I'm going to start writing smaller because I'm going to run out of space. So row 1 stays the same. Row 2 stays the same. Now row 3 is going to change. So we're multiplying row 1 by negative 3. Everything in row 1
What?
by negative 3 and adding it. So negative 3 plus 3 is 0. Negative 3 times 0 is 0, 0 plus 0 stays 0. Negative 3 times 1 is negative 3, bless you, plus 0 is negative 3. Negative 3 times 1 is negative 3, plus 0 is negative 3. Negative 3 times 0 plus 0 is 0. And then we get negative 3 times 0, which is 0, plus 1, which is 1. Can you guys see that, or is that too small? Okay. Well, that was nice, because now I've got a 0 and a 0 there. Let's head up and get this to be a 0, this 2. Row 2,
Negative 2 times row 1.
negative 2 times row 1. Negative 2, row 1 plus row 2. So row 1 is not going to change. Row 3 stays the same. All right, so a negative 2. I'm writing too small for my own good. Negative 2 R1. So negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 0 is 0, plus negative 2 is negative 2. Negative 2 times 1 is negative 2, plus negative 1 is negative 3. I'm just saying all this out loud so I don't make any mistakes. Negative 2 times 1 is negative 2, plus 0 is negative 2. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 0 is 0, plus 0 is 0.
Charlie,
Yeah.
so we don't have to like change the right side of the matrix, because that's going to be our answer.
That's going to be your answer. So you just got to keep doing the right operations and do your arithmetic right over there. Okay. Let's turn this into a 1.
1/3, negative 1/3.
Yeah, let's do negative 1/3 R3. So we do a negative 1/3 R3. Row 1 has not changed. Row 2 has not changed. Row 3, 0, 0, 1, 1, 0, negative 1/3. That's okay, I don't care about that fraction. It's alright. We can have fractions in our answers. Alrighty. Let's get this, so we got our lower left-hand corner. Before I turn that negative 2 into a 1, let's turn this negative 3 into a 0.
Times row 3 by 3.
Yeah, why do we want to do row 3 and not row 1? Right, if I did a row 1, if I did 3 times row 1 and added it to R2, this 0 would go away. So then it would be 3 plus 0, and that would turn into a 3. So we want to use row 3 because it has all zeros. Bless you. So let's do a 3R3 plus R2. So 1's staying the same. Bless you. 3's staying the same. So now what's 2 going to change into? Well, 0 times 3 is 0 plus 0 is 0. 0 times 3 is 0 plus negative 2 is negative 2. 3 times 1 is 3 plus negative 3 is 0. 3 times 1 is 3 plus negative 2 is 1. 3 times 0 is 0 plus 1 is 1. 3 times negative 1/3 is negative 1 plus 0 is negative 1. Okay.
Now we want to change
Do you want to get this? Do you want to deal with the fraction first, or do you want to get that to a 0?
that's a 0.
Yeah, let's go 0 first. Let's leave those fractions for last. So how am I going to turn this row 1, column 3 element into a 0? Yeah, so a negative R3 plus R1. So 3 stays the same. 2 stays the same. So row 1, so the negative of 0 is 0, plus 1 is 1. The negative of 0 is 0, plus 0 is 0. The negative of 1 plus 1 is 0. The negative 1 is negative 1, plus 1 is 0. The negative of 0 is 0, plus 0 is 0. The negative of negative 1/3 is positive 1/3, plus 0 is 1/3. Almost there. Last move. Yeah, negative 1/2 R2. All right, so 1 stays. 0, 0, 1/3. 2 becomes 0, 1, 0. So negative 1/2, negative 1/2, positive 1/2. 0, 0, 1, 1, 0, negative 1/3. So we got the identity matrix on the left. Let's hope that this is the right inverse. So my final answer, question?
Can you change the fractions or no?
Nope. It is what it is. So A inverse is 0, 0, 1/3, negative 1/2, negative 1/2, positive 1/2, 1, 0, negative 1/3. Forget if this was an answer in the book or not. It was. Did we do it right? Bam. We did. All right, so I'm going to show you how you can use your calculator to check to make sure that you did it right. So if you have your calculator in hand, you're going to be like, oh my goodness, how quickly your calculator can do all that work that just took us 10 minutes to do. So if you have a calculator in hand, remember how to input numbers into a matrix. So you hit second and then x to the negative 1 to get into the matrix. We want to go over and edit. Let's go to in and change A to a 3 by 3. And what were our original numbers? 101. 2, negative 2, negative 1. What? Oh, that doesn't like my negatives. Downfall of the calculator. 3 by 3, 1, 0, 0, 1. Negative 2. Negative, or positive 2, not negative 2. 2. Negative 2, negative 1, and then row 3 was 3, 0, 0. Yeah? Okay, so once you have that inputted, hit second in mode to quit out and go back to your main screen. Now we want to do the inverse of matrix A. I'm going to go back in and select matrix A under our names. And then I'm going to hit this inverse button, the negative 1 power, it's the sign for your inverse. Hit enter. Did we come up with our answer that we just got? Hopefully.
You hit math, enter, or something to show fractions.
If I hit math, enter, fraction it. Yeah, nice.
I don't know how to find that.
Which?
You how to find the inverse.
So did you input your numbers?
Uh-huh.